So I'd like to say Happy Christmas, and this is my little thank you to the Freecad community for a fantastic piece of software, one of the most fun things I've found this year. I've had a lot of problems with folding and the different assemblies, from assembly 2 plus, assembly 3, assembly 4. When you have parts that are designed to fold on folds, they tend to suddenly fail for a variety of reasons. Faces get lost, orientations get lost. It's been very difficult. But I've found a really nice way to do folds using nothing more than the standard part, and that's what I'm going to show now. So the first thing I'm going to do actually is I'm not going to create a body. I'm going to create a part. This is our origin part. And we're going to rename this to, let's just call this base. Oops, F2, base, okay. And in here, I'm going to create my sketch for the base object. We're going to put this flat, everything's going to be flat, and we're going to fold it. So let's just create a rectangle, and I think we will, what's the best way of doing this? I think what we're going to do is we're going to just do it like this. Starting on the origin in one corner, we're going to constrain this horizontally. Let's just give it 5 centimeters, and we're going to constrain this vertically, Shift V, 5 centimeters, magic. I'm on touchpad mode, so Shift to move the cursor. That's constrained, magic. And let's just pad that up. Blah, blah, blah. I'll make that 2 mil, because that's like a typical card thickness, especially if it's a wave card. And then Alt and move the mouse to rotate, so we can see what's going on. Now, this is where things start to get interesting. I'm going to add another one of these. First of all, we'll have 2 sides that fold together, and then we'll modify them to create the dovefold. Now, I want something attached to this base, and the best way to handle this now is to create a nested part that's inside that base. So it's relative to the origin of the base. So this is the origin of its coordinate systems, 0, 0, 0, and this part also has its origin there. So what we can do is, we can just, for example, transform this part. So the origin is now here. So it's either going to, well, this is going to be the side part here. So we're going to, as we rotate this part, transform, it's going to have the effect of putting the hinge there. Okay. Now, if you're going to laser cut, you'll laser cut from above. So you'll only be rotating these parts away from where it's been cut, but that'll become obvious. You might also want to consider defining these lengths in a spreadsheet, and in part, in placement, constraining this with an expression from your spreadsheet or your variables. Okay, so in here now, let's create another body. I could duplicate it, I could link it from the other body, but I think I'm just going to create another body, place it in that part. That can be quite annoying, how new things in Freecad get put at the bottom of the list, but it's just the way it is. Put it on the XY plane, and now we will do the same thing again. We're going to modify this in a bit. So Shift H for horizontal, 50 millimeters, Shift V, 50 millimeters, close it, pad it, 2 mil, magic. So now we already have a 100% reliable fold that folds exactly where we want it to fold. Superb. Let's do the same thing here. Let's get rid of some of these origins, they're confusing. We're going to have another part attached to this base, so let's nest it inside base. Now, we're going to move, well, in fact, we don't actually need to move it. We could actually just create the sketch in this quadrant here if we wanted to. So let's just do that. I don't know why it looks like these are still active, but they're not. Very strange. Anyway, body, place the body in here. I don't even know what that means. Single geo feature group, I get that bug, that error sometimes. I don't actually understand what it means. Let's create a sketch, put it in the XY plane. To make our lives easy, you can see if it's in this quadrant here, it's going to be in the right place. Horizontal, 50, height, 50. Oops. Okay. And we're going to pad it again to, right. So what we're going to do now is we're going to think about how to manage the folding. If we just quickly go into spreadsheet, we can create a new sheet, and in that sheet we can say something like hinge angle, and we'll give it 0 for the moment. Right click on there, give it the alias of hinge angle. This is what you're going to refer to it as, and I like doing it like this because I can also add some comments. The angle at which the sides are currently folded, because you might have multiple hinges, because you want, for example, to animate it and some hinges to fold before other hinges. So what we can do now is back here we can look up in fact I find the best way to handle this is to transform first of all the face, the part a little bit in the direction you want, because then the axis gets set up correctly around which axis it's rotating, and there's the angle. And now we can just go spreadsheet hinge angle. Okay, so we've set up the hinge angle with an expression here, and we're going to do the same thing here. We're going to transform it around, in this case, the red axis, just to get a feeling so it sets up the axis correctly. And now we're going to, in here, go, oh, there it was already, spreadsheet.hinge angle magic. So if in my spreadsheet now I change my hinge angle to 90, I go back in here, and there we go. Our box is folded. So the next thing is going to be, how would we securely join these two faces? And that's where the dovefold comes in. What I'm going to do is I'm going to create a separate sketch, and then we're going to attach it to each of those parts, in a nested way, and we're going to subtract it from each part to make the slot into which the tab will then fold. So let's get on with that, and it'll all become clear. We will first of all make a new part, and in here we're going to do the usual procedure. We'll create a body, we'll create a sketch on the XY plane, and this time, actually let's just hide all of this. This time we are going to, I'm just thinking about the best way to place this. Okay, so we're going to create this dovefold part around the origin. Lovely that it's Christmas, and it's lovely that the kids want to show me how far they've got with their Lego, but practically impossible to concentrate. Okay, so we're going to make a symmetry around the vertical axis by selecting those 2 points in the axis and pressing S. The same thing here. These 2 points, this axis, press S. We're going to define the height of our dovetail by selecting these 2 vertices, Shift V for vertical. Apparently I haven't selected just 2 things. must have already have been selecting the axis. Shift V, we're going to make that say 15 mil, and then we're going to select this horizontal. We'll make that 40 is a bit much, let's say 30, this one 20, and we should have a well-defined dovetail. Okay, so it's not really a dovetail in like the woodworking sense, but it has some similarities. I'm going to make that pad 2 millimeters high. Okay, lovely. Now you're going to see why it's really nice to work with parts and bodies, because the part can take care of rotation, whereas you can use the body to handle things like transforming things into the right position, where the part is still rotating the axis of rotation. And it's a really nice way to separate things. In fact, sometimes I find I'm creating a part for the fold and then a part for the content positioning outside of the body, but that's obviously a preferential thing. So let's unfold this. And now what we're going to do is we are going to make a copy of this part with everything. Yep. Are we going to take everything? Yes, we are. Okay, good. Again, with this geo feature group. Someone explain that to me, please. And what we're going to do now is we are going to move. First of all, we're going to rotate this because we want it along this edge. Okay, that's good. Now we're going to move the part, because that contains the axis along which we want to rotate, into position. So usually I'll do this with expressions. Okay, and then we're going to do the same old trick as before. This is actually part 4. We're going to rotate it in roughly the direction we want, and then we're going to add in our expression, which I should probably just copy paste, but it doesn't matter, it's not so much work. Hinge angle. Okay, and the same thing here for part 3. We're going to use the body to transform its orientation like that, and then we're going to use the part to position its origin system. So this is a lot like it works in Assembly 4 actually, except that Assembly 4 has some weird problems. Now these are actually going to be too large, aren't they? So let's just, if I'd linked them I wouldn't have to monkey about now. I could change one sketch and they'd both update, but never mind. So call it 20, let's make this one 10. And we're going to do the same thing with this one. 20 and 10. Right. Now let's move the part, I think would be better, so they don't collide. Okay. So let's see what happens now. Did I set both of them with a rotation? No, I didn't. So we're going to just transform this into position ever so slightly around the red axis in this case. And then we're going to go angle, spreadsheet, hinge angle. Right, spreadsheet 90 degrees please. Well, I obviously did something wrong, didn't I? What did I do wrong? I didn't nest them. It's rotated them around where they were when everything was flat. So let's go back, and now we're going to do the magic. Part 1 should contain part 3 nested, and part 4 should be in part 2. So this coordinate system is going to be rotated, which of course is going to rotate this with it. Maybe I should have chosen different lengths and measures here.